Hey kids, so let's get through some of this math that we got to deal with. The specific heat we talked about here. Here's a list of them that you'll always get. And hopefully, we learned with the oven in the back of the room when we were doing all that, that the specific heat is just one of many things that factor into whether or not you're going to feel the hot sensation by touching something. So, temperature is important, specific heat's important. Density is important, which is listed here as well. You can see that even though styrofoam and air have high specific heats, right? Styrofoam and air, they have very high relative specific heats. The fact of the matter is, you can't get enough grams to touch your skin to really make any difference for those things. And so, even though the room is full of air and the air might be cold, it doesn't do the job of, say, if you had ice on your skin or hot metal, because the density would be greater and often the mass is greater. So there's a lot of things that go into whether something's going to burn you or not, but specific heat is one of these things. And the nice thing about specific heat is figuring out how much heat is exchanged for certain situations. So we see here the equation we gave you. So you can replace this Q with a J for joules. Q doesn't make any sense. We've discussed that at length. So if it helps you to remember this, to rather think that joules is equal to mass times the change in temperature times, and you want to call specific heat like that, capital S sub H or SH or whatever you want to do, that's not a problem. You will never be asked, what does Q stand for? All right, so here we're just going to plug all these things in. We have 50 grams, so that's a mass. We have 20 degrees to 80 degrees, so that's our delta T. And one thing you want to do with the delta T, you want to make sure it stays positive. It's just going to make your life a lot easier if you always keep it positive. So 80 minus 20 is 60 degrees Celsius. That's better than taking 20 minus 80, or if in some situation, if I ever ask you about Q being positive or negative, you were pretty good about understanding if it gets taken away, it's negative, and if it gets added, it's positive. So I would just do these equations using a positive number all the time. And then if I ever ask you to assign a value of negative or positive to the joules, you can figure it out at that point. All right, so moving on, here's your specific heat, which is given. So if we're looking for the amount of heat, which is joules, we would do that by saying joules is equal to the mass, which is 50 grams, times this change in temperature, which is 60 degrees, and times the specific heat, which is 0.449. So you just multiply all those things. This is joules per gram degree Celsius. And we talked about how grams cancel there and degrees Celsius cancel there. So all you're left with is joules. Like the units are trying to tell you how to do this. So 50 times 60 is 3,000, and 3,000 times 0.449 is 1347. So the J equals 1347 joules. And if you were doing specific significant digits, that would be 1350. All right, moving on. Here's the new one. So this time we still have, here's the joules. So now we're given this first thing. The change in temperature, keeping it positive, would be 55 degrees Celsius. And here's the specific heat. So the thing we don't have, we have this, we have that, we have this. We're looking for the mass. So that's our question mark. So we have 566 joules is equal to our mass, which we don't know, times our delta T, which is 55 degrees Celsius, times our specific heat, which is 0.385 joules per grams degrees Celsius. So we do this math. We're trying to isolate that M. So 55 times 0.385 gives us 21.17. So this is 21.175. Right? Our M is still there. And we need to find what that is with 566 joules. So we divide both sides by the 21.175. So 566 divided by 21.175 gives us, really? No, 566 divided by 21.175 26.7 grams. So the mass is equal to 26.7 grams. All right, so that's 566 divided by 21.175 equals the mass. All right, not my prettiest work, but you're used to that now, aren't you, kids? All right, so here, this is one of the harder ones we have. We have our specific heat here, so that's done. We have grams, so that's done. We have joules, so that's done. So you notice there's a temperature, and if we throw the temperature in, then we would have everything, but that's not the case. This temperature is only part of the thing. Remember, we have two temperatures. It's looking for the starting temperature. So the delta T is what we're looking for, and we have our final temperature. I would just plug everything in here, solve for your delta T, and figure it out. But if you want to start putting in the 35, x minus 35 stuff, that's fine. But I would just put everything in here. So 468 joules is our heat. Our mass is 25 grams. And our delta T is what we're looking for. And our specific heat is 4.18 for water. That's joules per grams degrees Celsius. So to find delta T, we're going to multiply 25 and 4.18 times 25 is 104.5. So 104.5 delta T is equal to 1468 joules. And then to get delta T, we're going to divide both sides by 104.5. So 1468 divided by 104.5. That time I did do what I was supposed to do. So delta T turns out to be 14.04. So 14.0 with three significant digits. And we're actually supposed to have two. No, three. Okay. So now the next question is, do you add 14 to 35 or do you subtract 14 from 35? And since it says the thing was heated and it reached a temperature of 35, it would make sense that the temperature we're looking for plus the 14 is going to be equal to 35. Hopefully that makes sense, right? Something happened to heat up the water, and so we had an initial temperature and we ended up at 35. So then your temperature initial is equal to 14 is 1 and 21. 21 degrees Celsius is where you started. All right. There you go. We'll talk about that tomorrow. Hope you all have fun with this, and I will talk to you later.